Beer-Lambert law that will be used for this experiment. Okay, Beer-Lambert law. You can use that Beer-Lambert law for this calculation type later on if you want to, and that will be the absorbance is equal to the constant here that I think we already have discussed it later previously, that absorbance none of them are working. No ink. I also forgot to bring up. Okay. So Beer-Lambert law, of course, you can find it from the tutorial as well. I think in the tutorial there are somewhere it will be the Beer-Lambert law. So you can find it, and then you can discuss as well. So before that, before going to the Beer-Lambert law, what we'll do is this is the UV visible absorption spectroscopy meter, right? Students need to see that. Oh, this is the UV visible spectroscopy. I will show you later on. So this instrument, this machine actually will measure based on the light it is absorbing or passing through the samples, right? So the light is coming from one side, sample is in between, the light is then detected by another side. So how much light is passing, absorbing or transmitting? One inverse absorption is the transmission, right? So how much light is coming through that sample, based on that, it will remember or it will detect the concentration of the sample, so that you understand when the sample has to be colorful. If it is just like watercolor, no color, it will not absorb or it will not tell you anything. It cannot tell you how much sugar or how much salt you have dissolved in the solution unless it makes the solution colorful, right? So based on this, we will try to what? So many insects here? The fly? Or it is only coming to me? Okay, so what we'll do is sodium salicylate. The salicylic acid will be produced, and I mean the salicylic acid. Actually, what is that? Sodium salicylate, right? Sodium salicylate, and it is used for some painkiller as a painkiller, mild painkiller sometimes. So these things, the concentration of the sodium salicylate in an unknown solution. Where is the unknown? Do you have unknown on your table? The solution, any unknown solution do you have? It should be in probably in 3 or 4 fuel mode. Probably in 3 or 4 fuel mode. What is that? We find absorbance. Yes, we will find the absorbance. Okay. So what we'll do is we will find the absorbance of the sodium salicylate. But the interesting thing is sodium salicylate itself does not produce any color. So we have to mix it with ferric chloride, right? Ferric chloride, sodium salicylate, it will produce a blood red color. And the concentration high, the concentration of both, the darker is the color. The darkest it will be. The more dark the color will be, or more, how to say, yeah, the heavier the color is becomes. So based on these, we will find the concentration of how much sodium salicylate is there. If we know the concentration of iron, ferric chloride, then we will also be able to know how much of sodium salicylate was added there, right? So for the preparation, we will fill up with 150 ppm. What does ppm mean? If I want to, can I ask? I want to ask a question today. Start from the right side or left side? You guys are lucky that I'm asking question to you guys. But 100 ppm, 150 ppm means how many gram or milligram? 150 ppm means how many gram or milligram? Huh? Yes, 150 ppm means 150 ppm, I mean, milligram per liter, right? ppm is milligram per liter. So there should be somewhere, the solution should be given somewhere here. The other side, yeah. So it should be in the fume hood 5. The solutions and unknown and everything is given. Take from there, fill it up your burette, and then you prepare the solution according to the steps that given, right? But when you are taking this ferric chloride is always 5 milliliter, sorry. So it is easy to take, and it is you will not make much mistake taking 5 milliliter each time, every time. But when you are taking 5, 10, 15, 20, be careful. Because if you are missing any 1 milliliter more, then you are actually, this is your standard, you are preparing the standard. If your standard is not correct, any of them, then your unknown is also, I mean, you're finding the unknown is not that correct, right? But and one thing is, if you are making a little mistake for one of these standard, like for 10, you will take 0, 5, 10, 15, 20, any of them, you slipped a bit. For 15, let's say, or in the middle, let's say for 15, you take 14.9 or 15.1. How much will it impact your result? Can you just predict? I know that you don't know it, but I ask you to just predict or think how much will it impact your finding the unknown? How much? What do you think? Hold on, I take a pen marker. There are so many markers, but now none. Wait a bit, yeah. This is the corridor for our lab. I'm going to the other lab to find if there is any marker. Whiteboard marker. There should be. Only now this is the problem. Find it. Yep, I got it. Okay, found the marker already. Okay, so let's say that how would you produce or make the calibration curve? How make the calibration curve? Sorry. How you make the calibration? With what help? What is the tool that you will be using to produce a calibration curve? A graph, right? Yeah, that is the thing. A graph you will take. I don't know if they can see or not. So difficult. But they cannot see that. They'll say that is too far. Okay. Okay, you can see. You can see it. Later I'll bring it. For what you but only the thing is uh, why. are getting for 5, 0, 5, 10, 15, 20. 0, the absorbance will be 0. But sometimes it can change because probably your sample will have to be reduced and your water may have. From 5, let's say you get it here. 1, 5, 5 here. This is 10, 15. So, and again, let's say that 50 you get the point here, 20 you get the point here, right? So I bring it close probably for the online students. What I'm doing is, this is the concentration. I'm making for the calibration curve. I'm making it. See, they cannot see. I know. Why? What happened? Huh? Can you hear now? Hello, can you hear?
Yes, yes, sir.
Okay, okay. So, thank you for unmute and talk. Otherwise, it's difficult for me. Okay, so this is the calibration curve. This is how you produce the calibration curve. That's what I was saying. That usually and ideally, you will get a straight trend. Straight trend you will get. It was supposed to be here. The 10 was supposed to be here so that it gets straight. But I was saying that, let's say the 10 is a little bit deviated from, you make a mistake, or let's say you make a mistake, right? It's a random error you produce. So that when you produce a little bit error, somehow it becomes not that high, a little bit less. And the data you produce in this way, the curve, the line, right? So when the unknown, somewhere you find the unknown, the absorbance, you make the line and then you find it here, something. In this case, if it is like that, if unknown is there that I found, this is unknown. Unknown. Is this acceptable? Why? It's not within the range that I have taken, right? So let's say I just use a little trick of drawing it here. I bring it within the curve and I found the unknown here, right? So usually we'll find this way, the unknown, right? So if just 1 or 2 points, we do not make it very carefully, a little bit deviated, it is not going to make a big impact because this trend line is not depending on 1 point only. It is depending on 4 points. And that is why standard, the more the merrier, right? You make here, it is 4, I think you're making. If you make 10, it is even much more better and much more precise or accurate. It will be, but of course we cannot make that much, that many. Yeah. But that's what I'm saying, that even if it doesn't impact that much, but try to make as neatly, as precisely, as correctly you can do it, so that you get a very good result. Right? So yeah, that is one. And another thing, absorbance is epsilon B or C, let's say. Epsilon C and L. This is the Baer-Lambert law that will be used. This is absorbance. This is absorbance. This is epsilon is the constant. This is the constant for this type of absorption. C is the concentration. That is what we need. And L is the path length. Path length. Okay, path length for this type of absorption spectroscopy is usually 1 centimeter. The cuvette, the width of the cuvette is the path length. That is the only path, or that is the only space the light is interacting with the sample. That is called the path. Okay, so probably if you want, you can use this thing to in your report as well. Okay, now you will do exactly as it is given in the module manual, but I just want to tell you about. Can I have some space here? I want to show this thing. Yeah, I'll just. Everyone is having the Ford spectrometer, so we'll be using it. This spectrometer, everything is set, right? What color? You can see this is a nice one, spectrometer, and then the color is, you can actually visually set the color. This is the ultraviolet region. This is the red, and then it's going. So which one is shorter wavelength? Why? No, I'm sorry, stupid question. Why? Yeah, ultraviolet is the shortest wavelength among the visible wavelength. Well, do you know what is that wavelength? The ultraviolet. Okay. 400 and 700. Yes, good. So actually, not 380 to 700. So yeah, the lower the wavelength goes, it becomes ultraviolet. So ultraviolet is bad for our health, yeah, skin. Why? Why ultraviolet is bad? You use the color, the what is that called? Lotion? Sunscreen, yeah. What is the SPF you use? 50. What does it mean? What does it mean? 50. You don't? I don't use. Okay. You use. She use. She? They use it. And 50, what about you? SPF 50. What does it mean, SPF 50? Huh? Sun protection unit 50? Or I don't know. So 50 times you can stay more than us that we don't use. Is it? I don't know. I'm just making breaks. Okay. So yeah. Oh, this is because it is harmful because it is smaller wavelength. It can penetrate through the skin. It's not necessarily it makes it black. Okay. Black is our skin black because we have a lot of melanin and we can stay in the sun more than those who don't. All right. So where was I? Yeah. So this everything is set here. Everything is set up. Our lab assistant set up everything. What you need to do is you see that the cursor is jumping. Yeah. So we just need to put what is the wavelength we will be using today. 535. 535. So we just need to press 535. I forgot actually here. 570 or 535? 535. Just set 535 here, right? And that is it. So after that, what you will do is you bring it and lift it up. This is the cuvette. You should put the cuvette. Where is the cuvette? Oh, that should be cuvette there. Yeah, these are the cuvettes. So for this cuvette, right? See, take every group actually, take one. Take one. No, you can take more, but I want to show you one thing. Okay. So this is one, this is another one. All right. So here, see, take this one. Yes. So you see that here, take. In my hand, what I'm holding is a little bit. Yeah, now can you hear me, guys?
Yes, sir.
Thank you. All right. So now what I'm saying that this is the cuvette you have in your hand. My one is a little bit grayish color. You don't want to use that. You want to use the clearest cleanest, the most transparent one, right? Because if you use the grayish color, it is going to start the light. It is going to stop the light from passing through, right? And another thing is here that you will see a triangle is on one side, right? Triangle in one side, it will go through here. So this is the triangle on one side, and that two side is directly opposite is clear, right? This side is, there is a triangle here on that triangle mark actually, and this two side through there is much clearer than there. This is opaque. This side is opaque. This is much clearer. You can also see. So this clear side or the transparent side should go here, so that the light can pass through the clear part. So these two parts, the light is coming from here or going there, I don't know, or maybe from here to going there. So this path should go the clear path, right? It should face the clear path. Another thing is, every time you take the solution, sorry, every time you take the solution, wash it. Wash means rinse it, don't wash. Just take a little bit of the solution that is going to take. You have a lot of solution, you don't have to worry about it. Just take a little bit of it, maybe a little bit. Yeah. Maybe you can take a little bit of it and then just rinse it before you use it. Rinse it means you smear. Sorry, it will not break. It will not break. Don't panic. I broke quartz one when I was working as my research. So it was very expensive that time, and I was so very shy. Anyway, my supervisor was very good. He paid for it. So yeah, it was quartz. That time we used to have quartz. We had this one, but for my research, I needed a much. This has some degree of transparency problem. Quartz doesn't have. Anyway, so yeah, I was saying that, okay, so you take a little bit of it, a little bit, and then smear it all the side, so that, and then throw it, the sample, before you use it. Otherwise, because this instrument is quite sensitive, if there is anything trace, it will give you the result based on that, right? Another thing is, you shouldn't touch these two clear side. Do not touch clear side, because if even it does not look that it is nothing, in the micro level, probably our hand is putting some moisture or some fingerprint mark there, right? Some fingerprint mark. So before you put here, make sure that, and another thing is, you do not need to fill it up totally until this mark, like half of a centimeter, you clear it from the top. The solution, half of a centimeter from the top, you clear it, keep it clear. No need to fill it to the brim, right? Another thing is, before you put it here, you take a tissue, wipe the side, these two sides, all right? Wipe the two sides, make sure it is dry, and also there is no mark on it or anything. Or if there is any bubble inside trapped, it will give you a wrong result. So it shouldn't be any bubble as well. Any bubble, right? And yeah, that is, and then you have to take a blank first. Take a blank, like blank means distilled water, just distilled water, because we are preparing the solution with the distilled water. So distilled water should be used as a blank base, right? So take the distilled water, put it here inside, and then cover it. And for the distilled water only, make it 0 like this. Press 0. This one, the yellow button. Press for water only. For the, I mean, not water, for the blank. Blank in this case is water. Sometimes we have other solution that we use for preparation. So we will use that one for blank. Put it here, press 0. All right, that's it. Then just 2 seconds it will take. Lift it up, take this one out, the water, put it on one side, take your sample in the another cuvette, Of course, you rinse it and do wipe it, put it there, cover it. That's it. It will give you a result here, absorbance. You don't need to touch anything. Understand what I said? Right? First, you set 535 here, and then put the blank, that is water. Press 0. Right? Take it out, put it aside, put your sample here, and then no need to press anything. It will directly give you the result. Right? So you put one blank, that's it, and one after another, one after another, one after another sample, you can test it. Unless you have changed or you have left it for some time or changed the absorbance or anything. All right. Until you unless you change anything, you don't need to do anything. You can just use the same blank, same setup. It does not take long time. Only the preparation of sample will take time, but I will not give you any more extra time than 6. All right. So yeah, you can start now. Online students, anyone has any question?
Sir, I have a question, but it's based on the last experiment.
Please, yeah.
I have a question, but it's based on the last experiment.
Yes, ask, no problem.
Okay. Sir, in the experiment, it says you have to paste 3 chromatograms, but I've only got 2.
2 chromatograms. Sorry, what? You only got 2.
Yeah, and then it says there are 3 tables in the experiment, and then it says you have to paste 3 chromatograms, but I only got 2 chromatograms.
So only 2 band means 2 color, you say?
2 chromatogram papers. You know the.
Oh.
They did, I think they did the result, and they.
Chromatogram, there should be all 3 samples should be there. I think all three samples. That means food dye, then ink, and also the unknown, right? So ink for pen ink
Yes,
in
sir.
one
I don't.
on pen ink should be on one paper, and your food dye and unknown should be in another paper.
Yes, sir. I don't think I have my ink paper.
So you ask your group member to send it for you then.
Okay. Okay. So I posted a comment in the discussion. It's yet to reply.
There's no reply yet?
Yes, sir.
Okay, I'll see. Please, everyone, send your results to your group members. Yeah? Yeah. Okay, so what I'll do is, hold on. You don't need to turn on the video mode. And also do not discard the things in the sink. Please discard it. Put 5 There is a voice bottle, please discard it there. Do not throw it in the screen. If you don't need to turn on the pure mode today, it's not volatile, yeah? No need to turn on. So anybody has any question yet online?
Do we have to separate it into volumetric cost or into chemical cost?
What is this one?
It's kind of confused for the step 3. Like this one, repeat the step 2 by preparing the 4 solutions.
Do we need it to be in flux or volumetric cost?
Like, are we using this one? Are we using the same concentration?
For this, it's the same. 5, yeah. This is also same, right?
Yeah, for this one.
But only the volume is different. So it mix together.
Mix together.
Yes.
Just mix together.
Yeah.
Yeah. Yeah. For this one. This is the same. For this one, right? We use the diluted one or the undiluted one.
This is the concentration. Do you have this concentration? 6 times 10 pound 83rd. That means 0.006 molar. Do you have that 0.006 molar?
That is.
Yeah.
That's on the time, right?
Yeah, 5 milliliter. It should be given, right?
Yeah.
It should be given. Is it given? Do you have it? 0.006 molar. 6 times.
You fix it.
Here is the chloride solution here. Then take 5 milliliter from here. And then mix it with that 5 ppm. I think we need to do good. Because for this one, this is the we use the diluted one. Diluted very we should not be using the line. Should be using the one. Oh. It's so confusing. It's ridiculous. If you're talking so we should be using it for this one. Yeah, okay. And then your how many times, right? You have to check it out and then. We need something else. So the all the stuff we did, like use them from.
All right, I did this again.
Yeah. But this is now, you can come this something. Oh, yeah. Behind, come behind. Yeah, now see straight. Straight. Yeah. Straight now. In my eyes, things like that. Yeah, it's touching the lower. So now we see. Yeah, but just now,
Where's the stickers? Can you check this one for me too? Put it in.
Why is that in trouble for you?
It's not. This bottom part is touching. Touching the line. But the problem is that too much water is here. So if it comes down, probably it's going to increase a little bit. Yeah, increase the next time we should use the not like that. It's here with oily, it's not clean, that's why.
So next time, make sure that it's doing.
So can you hear me?
Yes, sir, we can hear you.
But can sir hear me?
No, I'm not sure. Maybe.
Using his wireless earbuds.
I thought sir was talking to us. That's why I responded.
Let's try it again. Sir, can you hear me?
Sorry, what is that? Sorry.
Yes, sir. So I gotta go. Can I leave?
Yeah, sure, sure. You're free to leave.
Oh, thank you, sir. Have a good day.
You too. Thank you. By the way, next week is the test, yeah? 27th?
Yes, on a Friday.
Yeah. So everybody knows that's good.
Software leak, but it's still weird.
Huh?
Our software leak, but it's still weird.
So what happened?
It leaked again.
You got it in a week.
Yeah, but it's still very.
Yeah. But it was like just now, this much, like it more.
I mean, now it's a bit less. Just now was a bit.
No, you prepare it, so it was not exactly, I mean, accurate volume. So you have to make it again. But if it were okay until this, and then you invert it, no leaking, huh? No leaking, no. No.
Yeah. Yeah.
If it is just now, my question, I mean, my thing is, my point is, if you are just now this part, and then it leak for inversion, no problem. But if it was not more or less, before, then you have to make it in. You know better. Yeah. What? Washing. Just now, for explaining this thing, if one of the points is a little bit not according exact here, then it should be okay. But yeah, if you redo it, you do it faster because it's all it's 520, yeah. 520, another 30 minutes for you to finish and then 10 minutes to clean up. Yeah. After you put the left, you press it. 535 left. No, sorry to press anything, please. No, you put the 10. Take out. So your online friends probably don't know whether they want to see you guys, what you're doing. Can you give a live commentary of what you're doing?
We are thinking on how to do this.
This what?
How to do that tutor.
How to what?
Do you have to use a dropper or do we just?
No, you can use that one, yeah. Just use a little 1-2 drop, rinse it, then use fill it up later on. Okay, yeah, can rinse it. Throw it in the other, yes. This is what? Is the blank? Oh, for the blank, Francis, for the blank, did you put water or the blank one?
The blank.
Oh, good. I think I told water, right? So sorry, that was my mistake. Huh? Yeah, you take the blank first, then solution 2, 3, 4, 5, like this, right?
Where will they show the result for this?
Huh?
Which one I think here, right?
Can you close the lid? Yes. Yeah. What?
Right. Is there anything I should record down?
No. Just record down the absorbance. That is blinking, right? That you should put it here. I mean, put that. Record it here, and then nothing to do. Nothing. No need to press anything. Just take another cuvette. Take sample. Just put that, and then record the data. Have you rinsed? So you don't want to rinse?
Yeah, you don't. Okay. So
Just throw it. Not in the sink. Not in the sink. Yeah, there. Keep one beaker here. La. No need to go every time there. Later you wash all the beakers. Not enough. Not enough. Don't invert. See, you already. If it goes inside this rubber pillar, then your sample is already corrupted. Or what is it called? That. Yeah, forget. I'm hungry actually. No, really. I haven't had my lunch. A bit more. Yeah, should be okay. Should be enough. But make sure that it is clean. You wipe it. There is no bubble inside or no water. Yeah, air bubble inside and no fingerprint on the wall. Then put it inside. Going to show. Yes, 3 to 5 absorbance.
it's always changing. So
It will keep changing.
so which one do I choose? The one with the constant one.
Yeah, you see, it is 3 to 5, 3 to 4, 3 to 3. It's almost similar.
So
0.001 changes will not make any difference for you.
just on the
3 to 4, yeah.
we don't remember how to get the zero ABS thing.
Huh? Sorry? Have you put the blank?
Yeah.
Then put press 0. This one? Yeah. Yeah. Take it out. Open it. Take it out. And put the sample now. No need to press anything. If you put the sample, it will automatically give you the absorbance. Yeah. Take it out. Put. Yeah. You close the lid. Make sure that nothing goes in there. Yeah.
It's enough.
Hmm?
It's enough.
No, you want to fill up more? You want to fill up more? Do you want to fill up more? So why you asking enough or not?
Just for
Enough,
experiment.
enough, enough, enough. Yeah. Okay, so online students, this is for your lab 5 experiment procedure. The video I'm shutting down. I'll see you. There will be a exam, the test, mid-sem test on 27th. So yeah, but anyway, I will be online on Wednesday, 2:30 p.m. Right? If you have anything, anyone has to anything to ask for anything, I'm available through the MS Team links. I will put the announcement once again. So for the time being, bye bye. Take care. Have a nice evening there, or whatever. I mean, afternoon, or maybe. Bye bye.
Thank you, sir. Goodbye.